National Electrical Code, or NEC, does not have a specific requirement for marking a neutral conductor when it's used as a switch leg in a single-pole switch circuit. However, it is considered a sound electrical practice to clearly identify this conductor to prevent potential confusion and ensure electrical safety. The reason for this recommendation stems from the standard function of a neutral conductor, which is to carry current back to the source and is normally understood to be at or near 0 volts potential with respect to ground. When a neutral conductor is repurposed as a switch leg, it carries current only when the switch is closed, effectively making it a current-carrying conductor that is energized at certain times. Failing to mark the neutral conductor could lead someone to incorrectly assume that it is always at 0 volts and safe to touch, which could result in an electric shock. Here's a more detailed breakdown. Firstly, the NEC establishes minimum safety standards for electrical installations to protect people and property from electrical hazards. While the NEC is comprehensive, it doesn't cover every conceivable situation or best practice. Instead, it focuses on the essential requirements necessary for a safe installation. Secondly, Section 404.2a, which addresses switching, generally requires that all switching be done in the ungrounded or hot conductor. This rule ensures that when a switch is open, it disconnects the energized conductor, effectively de-energizing the load. However, there are circumstances, particularly in older wiring methods or specific control applications, where a neutral conductor might be used as a switch leg. Thirdly, local electrical codes and regulations can supplement the NEC requirements. It is essential to check with the local authority having jurisdiction, or OJ, to determine if there are any local amendments or requirements that mandate the marking of neutral conductors used as switch legs. These local rules can vary significantly depending on the region. Fourthly, even though the NEC might not explicitly require marking, it strongly encourages following industry best practices and manufacturers' instructions. Many electricians and electrical inspectors would advocate for marking the neutral conductor as a matter of safety and professional conduct. This practice helps prevent accidental contact with an energized conductor, especially during maintenance or troubleshooting. Fifthly, the recommended method for marking a neutral conductor used as a switch leg typically involves wrapping the conductor with colored electrical tape. Black or red tape are commonly used to indicate that the conductor is being used as an ungrounded or hot conductor. Alternatively, a permanent marker can be used to write the word hot or switch leg directly on a conductor's insulation. The marking should be clearly visible and durable to withstand environmental conditions. Sixthly, it is crucial to understand the color coding of electrical conductors. In North America, the standard color code is as follows. Black and red wires are typically used for hot conductors. White or gray wires are used for neutral conductors. Green or bare copper wires are used for grounding conductors. When a neutral conductor is repurposed, it's essential to alter its appearance to clearly indicate its new function. Seventhly, consider a typical single-pole switch controlling a light fixture. In a standard configuration, the hot conductor from the power source is connected to one terminal of the switch, and another hot conductor, the switch leg, runs from the other terminal of the switch to the light fixture. The neutral conductor from the power source is directly connected to the light fixture, providing the return path for the current. However, in some instances, the neutral conductor might be run to the switch box first, and then the switch leg is run to the light fixture. In this case, the neutral conductor is being used as a switch leg between the switch and the light fixture. Eighthly, when working with electrical circuits, always follow safe work practices. Firstly, de-energize the circuit before working on it. Use a voltage tester to verify that the circuit is de-energized. Secondly, wear appropriate personal protective equipment, or PPE, such as safety glasses and insulated gloves. Thirdly, follow the NEC and local codes. Fourthly, if you are not comfortable working with electricity, hire a qualified electrician. Ninthly, the NEC provides guidelines on conductor identification in Section 200.6. This section outlines the requirements for identifying grounded conductors, typically neutral conductors. While it doesn't specifically address the marking of neutral conductors used as switch legs, it reinforces the importance of clear and permanent identification of electrical conductors. 10thly, remember that electrical codes and standards are constantly evolving. It is important to stay up to date with the latest revisions to ensure that your electrical work complies with current requirements. Organizations like the National Fire Protection Association, or NFPA, publish the NEC and other relevant standards. 11thly, proper labeling and documentation of electrical circuits are essential for safety and maintenance. Clearly label all circuit breakers and panels and maintain accurate wiring diagrams. This information can be invaluable during troubleshooting and future modifications. 12thly, consider the potential consequences of not marking a neutral conductor used as a switch leg. Firstly, it could lead to accidental contact with an energized conductor, resulting in electric shock or electrocution. Secondly, it could cause damage to electrical equipment or appliances. Thirdly, it could create a fire hazard. 13thly, when in doubt, always err on the side of safety. If you are unsure whether to mark a neutral conductor, it is always best to do so. This simple step can significantly improve the safety of the electrical installation. 14thly, regularly inspect electrical systems for any signs of damage or deterioration. Look for frayed wires, loose connections, and cracked insulation. Address any issues promptly to prevent potential hazards. 15thly, educate others about electrical safety. Share your knowledge with family, friends, and colleagues. By promoting electrical safety awareness, you can help prevent accidents and save lives. 16thly, the use of a non-contact voltage tester can be a valuable tool for identifying energized conductors. This device can detect the presence of voltage without requiring direct contact with the wire, reducing the risk of electric shock. 17thly, consider the use of arc fault circuit interrupters, or FSIs, and ground fault circuit interrupters, or GFCIs, to provide additional protection against electrical hazards. FSIs protect against arc faults, which can cause fires, while GFCIs protect against ground faults, which can cause electric shock. 18thly, always use the correct size and type of wire for the application. Refer to the NEC tables to determine the appropriate wire size based on the ampacity of the circuit and the ambient temperature. 19thly, avoid overloading electrical circuits. Overloaded circuits can overheat and cause fires. Distribute the load evenly across multiple circuits. 20thly, never tamper with or bypass safety devices, such as circuit breakers and fuses. These devices are designed to protect the electrical system and prevent hazards. 21st, when making electrical connections, ensure that they are tight and secure. Loose connections can cause arcing, overheating, and fires. 22nd, use appropriate wiring methods and materials for the environment. For example, use weatherproof materials for outdoor applications. 23rd, protect electrical wiring from physical damage. Run wires through conduit or other protective measures to prevent them from being damaged by abrasion, impact, or other hazards. 24th, be aware of the potential hazards associated with working near water. Water is an excellent conductor of electricity, so avoid working with electricity in wet or damp conditions. 25th, when working on older electrical systems, be extra cautious. Older systems may not have the same safety features as newer systems, and the wiring may be deteriorated or damaged. 26th, always disconnect power before working on any electrical equipment. And always double check to ensure the circuit is truly de-energized before touching any wires.